All right, Chapter 1, Values of Piecewise Functions. This is the Chapter 1 notes, page 8. In the real world, it usually takes a combination of functions to represent a particular trend. For example, at the post office, there are different costs for mailing different objects like boxes, packages, pamphlets, letters, etc. And these are all based on weight ranges. Finding the correct cost depends on in which domain the weight falls. The categories or statements are called conditional statements, are your domains. You must find the condition that is met to determine in which piece you are to substitute to find your value. So, for example, in this first one that I have here, condition 1, that is the domain of this function right here, this guy's domain, says I'm less than 0, then my answer is 1. So when I'm ever less than 0, it simply means the value of the function is 1. So what are some examples of things that are less than 1? -1, -3/2, less than 0, sorry. -0.1, -pi, any negative number you can think of, the value is 1. Now we have a second condition, and the second condition says that, okay, you can be 0 in your domain or positive. So when I come to this second condition, any number that's the value of 0 or bigger is going to give me 2. So I could have just as easily said, well, what will f of 0 be? Well, 0 is in this domain because it's the equal to. So f of 0 would also be 2. This is where you all have your trouble. Condition 1 does not let me use 0. Condition 2 does. So the first domain is x is less than 0, and I can only use negatives. The second domain is x is greater than or equal to 0, and I can use 0 or positives. So now let's move on to one where we have statements in it. So the first domain, that is condition or statement, says that your x's must be 3 or smaller. Then I substitute into x plus 5. The second domain says, okay, if your x's are greater than 3, then you substitute into 2x minus 1, and you can find your value of g. So I've given several g statements here, and notice every one of these gx values is going to fall into the first statement because they're all less than 3. So since they're all less than 3 or equal to 3, I insert their value of x and add 5 to find the g value. So g of -1 is -1 plus 5 is 4. G of 0 is 0 plus 5 is 5. G of 1 is 1 plus 5 is 6. G of 3 is 3 plus 5 is 8. G of 2.1 is 2.1 plus 5 is 7.1. G of -pi is -pi plus 5. G of -2/3 is -2/3 plus 5. Now remember, what's 3 times 5? 15. 15 minus 2 gives me 13/3. Now for the second condition, all my next problems are going to be larger than 3, and I will substitute into the formula 2x minus 1 to find g. So g of 4, 2 times 4 minus 1, 8 minus 1 is 7. G of 5 gives me 10 minus 1 is 9. G of 7, 14 minus 1 is 13. G of 3.4 is 6.8 minus 1 is 5.8. G of 5.1 is 10.2 minus 1 is 9.2. G of 3 pi is 6 pi minus 1. And G of 10/3 would give me 20/3 minus 1. And 20 minus 1 times 3 gives me 17/3. Now for the last and final example, I'm going to give you where there are 3 separate domains, 3 conditions. Now, folks, you can have 4, 5, 6, but, I just want to give you the gist, and I'm going to call this function h. So as long as the domain is less than -4, I substitute into -2x plus 5 to get the appropriate h value. So h of -10 is less than -4. So I have 20 plus 5 is 25. -9 is less than -4. So I have 18 plus 5 is 23. -7 is less than -4. So I have 14 plus 5 is 19. -2 pi is like -6.28 something. And so it's less than -4. So I have 4 pi plus 5. -5.1 is less than -4. So I end up with 10.2 plus 5 is 15.5. -13/3 is less than -4. So I end up with positive 26, and 3 plus 5 is 15, and 15 and 26 is 41/3. Now, for my middle one, any number equal to -4 or bigger, but less than 4, the answer is always -3. Very easy. Notice every one of these falls into that restriction. H of -4 is equal to -4, so I get -3. -3 is between -4 and 4. -2.7 is between -4 and 4. 0 is between -4 and 4. 2/3 is between -4 and 4. Pi, which is approximately 3.14, is between -4 and 4, and 3.9999999 is between -4 and 4. And so all of these yield -3. For my final condition, if I am given a number that is positive 4 or larger, I substitute into 3 minus 2x. So all of these are 4 or larger. And so I end up with h of 4 is 3 minus 8 is -5. H of 5 is 3 minus 10 is -7. H of 10 is 3 minus 20 is -17. H of 12 is 3 minus 24 is -21. 2 pi is approximately 6.28. 3 minus 2 times 2 pi is 3 minus 4 pi. 3 minus 2 times 9.8 is 3 minus 18.6 is -15.6. And 21 over 5 is 4 1/5, so it's bigger than 4. And when I multiply, this will give me a 42 over 5. That's a 15. A 15 and a -42 gives me -27 over 5. So you can see these substitutions are real easy. You have conditional statements, that is conditional domains, domain 1, domain 2, and domain 3, and you just have to follow and plug in wherever it's appropriate. Piecewise, dippy, dippy, dippy.